Okay, in this video, we'll introduce you to and the next video will introduce you to the incredibly important ideas behind multiple regression. So our file is your regression start, regression data start. And it's got a lot of worksheets. Let's go to the data worksheet. Okay, so what happens in multiple regression, you have a dependent variable you want to predict. Okay, and what that could be in sports might be runs scored in a season by a baseball team. And then you have independent variables, x1, x2 through xn that you use for prediction. And Excel, unfortunately, limits you to 15 of these. There are ways around this, but not using the standard Excel regression tool pack. Okay. And so if you had runs scored in the season, you'll see in the next video, several videos from now, you might say, if I know how many singles, doubles, triples, home runs, walks plus hit by pitcher a team has, I can predict how many runs they score and then develop a way to figure out how good a hitter is based on this regression that you'll see. Okay. So another example of why it might be the QB rating in the NFL. Would do this here. We can make that red. And the quarterback rating in the NFL was based on yards per pass, touchdown percentage, interception percentage, and completion percentage. And if you know those four things, you can really nail very accurately or determine very accurately what is a player's quarterback rate. Well, then in basketball, you want to predict how many NBA team wins in a season. Well, it turns out there are four factors. Dean Oliver, who used to head ESPN Analytics, came up with this great idea. And the four factors are basically how well you shoot opposed to your opponent, how often you turn it over, how often you go to the foul line, and how well you rebound. Okay? And so those will be three examples of multiple regression that we will have in the course here. And there are many, many more that you could come up with in sports. Okay. So if you have a dependent variable you want to predict from independent variables x1 through xn, with the model of multiple linear regression, okay, we're going to do multiple linear regression. You'll see why the model is called that in a second. You assume your best guess is that y equals some constant, beta 0, plus another constant times the first independent, and you just multiply each of the independents by a constant. And why do we call this multiple linear regression? It's linear because we're multiplying the independent variables by a constant. Now, there are times you want nonlinear regression. If we have time, maybe we'll do an example. For instance, to predict player performance based on age, you don't want it to be linear, because that would say as a player gets older, he either always gets better or always gets worse. And usually there's an age up to which a player improves, and then they start getting worse, probably around age 27 to 30, depending on the sport. Okay. Now, it's linear because you're multiplying each independent variable by a constant. It's multiple because there's more than one independent variable. And it's regression because we say we're regressing y on the x-axis. Okay, so we're going to give you an example of this and show you how to run regressions in Excel. So this comes from my book, Marketing Analytics. If you're in the marketing business or just if you have any job involving analytics, this is a bit more advanced book than the Excel book that I've recommended. But I mean, it's gotten really good reviews on Amazon, maybe the best reviews of any book I wrote. I'm biased, I think it's pretty good. But it's John Wiley, I think it was 2014. Okay, and there's a chapter 10 there. Let me just check the chapter number, but I think it's 10. Yeah, chapter 10 discusses in great detail multiple linear regression. Okay, or the DAB, the data analysis and business modeling book has a few chapters. But Chapter 10 goes into much more advanced detail than the data analysis business modeling book. And there are plenty of good books on regression. And if you're going to be a sports analytics black belt, so to speak, you've got to really know everything about regression. Sometimes it's called econometrics if you take it in the econ department. And they're focused mainly on analyzing financial or economic data. Okay, and that's actually what we have here is what's called cross-sectional data. It's a certain point in time, I think 2007. It comes from The Great Economist, Pocket World Guide and Figures. And if you've got to read one source of information for your business knowledge, I recommend The Economist. I feel it gives you a balanced view of the world. New York Times is really liberal. The Wall Street Journal is really conservative. I read both and I learn from both. But basically, The Economist helps me think on my own about the important issues of the day. Sometimes has, I'm sure the cover next week will be FIFA corruption. I have not gotten it in the mail yet. Okay, but here's some economic data. We want to predict for countries in Europe sales per capita of computer products in a year. So for instance, Austria sold $112 per person of computer products in the year we're looking at. And what are some variables that can help you predict this? Gross national product per person. The bigger the gross national product, the bigger the country's economy. The unemployment rate, the bigger the unemployment rate, the less you probably expect they spend on computers. And percentage of GNP spent on education. The more that's spent on education, the more you think the country would spend on computers. Now, why would you want such a model? Well, you could set sales quotas for countries if you were working for Dell, HP, or Lenovo, or a computer manufacturing company on what you should sell in a country based on the economics of that country. So the idea is you'd like to predict the yellow from the red. So we're going to run a regression, learn about some basic concepts. So how do you add the tool to run regression? It's under Data tab, Data Analysis. But how did I get that? Okay, I go File, Options, Add-ins, and you check the Analysis tool pack. There's two choices. You'll see you check the first one. And that should bring it in for you. So if I would go File, Options, Add-ins, do not collect $200, and check the first box, Analysis Tool Pack, and click OK, and then you should see it right here. Okay, now to run a regression, you just go to Data Analysis. There's a lot of cool stuff here, which we don't have time to talk about everything, but regression. Now the Y range is going to be, I hit the little button to shrink the dialog box, is the sales per capita. The X range is what you're using to make the prediction. So I can click that little button again. And then I click the button to go back to the dialog box. Okay. Now, we have labels in the first row. You need labels or you don't know what your columns are referred to. And the new worksheet will say, I'm doing this in June. So it'll say June regression 1. Okay, and now there's a bunch of stuff down here. The only thing I care about is residuals. Residuals are the prediction from the regression equation minus the actual. And it's important to look at outliers and figure out what to do with the data points that don't fit the pattern of prediction of the rest, most of the other data points. We'll see Finland's a huge outlier. Okay. So we're going to put this in that new worksheet. Okay, so June 1 regression. Let me check that we're right here. Okay, we're good. Okay, so a couple of things that we want to talk about on the output. Okay, first of all, here's the equation. So there's your predicted sales per capita. In other words, the best Excel could do by multiplying each independent variable comes from the coefficients here. So it'd be minus, I'm just going to round off here quickly because this won't be our best equation, plus 0.002 times GNP plus 4.22 times unemployment plus 21.4 times education percentage. Okay, now first question you should ask, if you run a regression, you can throw stuff in that has no importance. If you want to predict how many games the Yankees win in a season, if you throw in how many toy stores there are in New York City, you're probably not going to get that to be an important variable. we look at p-values for the independent variables. So every independent variable has a p-value. In a regression. Between 0 and 1, and a low p-value, let's say less than 0.1. Some statisticians say 0.5, 0.05, means the independent variable helps us predict the dependent after adjusting for the others. Okay, so we look here, we see unemployment rate. I mean, the 0.11 here is fairly close. I'm going to leave that in because it's pretty close to 0.1. But this means there's a 40% chance unemployment rate doesn't help us. Okay, now how good is the fit of our regression equation? Okay, there's two measures here, R squared and standard error. So what do those mean? So the R squared is 53%. Our model explains 53% of variation in, let's just call it sales per capita for computers. 47% is not explained. How accurate is the model? This is the really important number. 58 is the standard error. And so that means this comes from the normal random variable, which will be discussed later in the class. For a normal random variable, and that governs things like height and weight, roughly 68% of your data is within one standard deviation of the mean, 95% within two standard deviations. So I double that 58. Okay, I get 95% of the forecasts by plugging in this equation should be accurate within 1/17. 2 times 58.5. Okay, so any prediction off by more than 2 standard errors is called an outlier. Okay, so if we're off by 1/17 or more, we have an outlier. So come down to the residuals that I checked. Residuals are the error, they're actual minus predicted. And how does Excel pick the coefficients in a regression? The coefficients are chosen to minimize the sum of squared errors. You square the errors, actual minus predicted, so positives and negatives don't cancel out. It's like we did when we tried to find the best Pythagorean exponent. And the sum of the errors will actually always be 0 in a regression, which is a beautiful property. Because what that means is a positive error residual means we sold more than the regression equation predicted. A negative means we sold less. The fact that they sum to 0, this is 0.12 zeros and a 5, means that sort of our equation splits the points in half. But let's look for an outlier, and we've got one right here. Finland. The 6th country is Finland. Nothing wrong with Finland. I'm sure it's a great country. Matter of fact, the book written on the smartest kids in the world had several chapters on the Finland system of education. And I think the general consensus was from that book that Finland really has the best K through 12 educational system in the world, mainly because they pay K through 12 teachers a lot of money and make it a valued profession. We could learn from that. Okay, so this 192, remember the standard error was 58. You double that, you get 116. So the Finland prediction's off by more than 3 standard errors. So that's a huge outlier. Even 2 standard errors is an outlier. Now you have to decide what to do with an outlier. I mean, can you explain it by adding other variables? I know nothing about Finland, to be honest. This is such a different prediction. I feel like I need to throw it out of the equation and run it again. There might be something in the way that maybe it's the Finland school system that we talked about, or maybe the way the Finland government handles, maybe they subsidize the purchase of computers. I just don't know anything about this. So I'm going to throw Finland out. So I've got a column, and unemployment rate had a high p-value. I'll throw that out. So basically, we'll leave unemployment rate in for the moment because we're not sure about what would go on with unemployment rate if we threw Finland out. So you notice here in the Finland out worksheet, there's no Finland. I deleted row 6, and I just ran the regression again. Again, I'm not going to spend the time on that, but you use this column as y values, and these columns will be your x values. You run the regression again, and you get the result in this worksheet regression 2. All right, notice there's 20 observations now. The R-squared leaped to 74%. The standard error is now 30 because that Finland observation had such an impact on our predictions. The standard error was about 59. Okay, now let's look at the p-values. Okay, GNP has a p-value of 0.004. That means after looking at unemployment rate and education spending, basically, there's only 4 chances in 1,000 GNP doesn't affect computer spending. There's an 84% chance unemployment rate doesn't affect computer spending, so we should throw that out. Now, what percentage is spent on education? What's the p-value for that? 4%. So that's useful. So let's see if we have any big outliers. If you double that standard error to 60, I think we've got one outlier there. Yeah, data point 18, which I think is Switzerland. Now that's barely above 2 standard errors, so I'm not going to throw that out. Okay, but we've done a lot in this video, but what we're going to do in the next video is toss out unemployment rate. You should throw out variables with independent variables with high p-values because they're just not useful. And so we're going to throw out unemployment rate, and then we'll see an example of throwing out an insignificant independent variable in actually our next first video using regression in sports. So we'll run the regression again, and we get all good p-values, all low p-values. Then we'll use that equation to predict computer sales, and that would be a decent equation. Okay, so we'll see you in the next video where we continue our discussion of regression.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytic stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.